Since the dawn of time, kickflips have been the epitome of cool, an achievement sought after by all, but truly known only by the most talented. Back in the time of the Neanderthal, humanity has sought to shred the gnar in a new and spectacular fashion. Religions worship the way of the board, dreaming about and chasing the true nature of shredding. But in the modern day, scientists have cracked the code. Know the key to cool. The secret formula to the kickflip. Today, I have the privilege of hosting this story as it unfolds. It is a wonderful breakthrough in human technology, folks. My name is Hank Anchorman, and I ask that you join me today as we journey to the edge of human knowledge, and we will be breaking down the science of the kickflip. We began the search at Dr. Kathy Shawn Laboratories in beautiful Toledo, Ohio, where our field reporter, Hank Hankerman, met the man behind the madness, Dr. James Coolius, Ph.D., the leading scientist behind the study. Thank you, Hank. I'm here with Mr. James Coolius.
It's Dr. Coolius. Thank you very much.
I'm sorry, Dr. James Coolius. Would you care to explain your findings to me, please?
Before I talk about the breakthrough of the kickflip, I feel it's necessary to talk about what we know about the ollie.
I see.
This is broken up into 3 steps: the pop, slide, and land. The pop, we start the board at rest, and then we apply a force of a push, where then it pivots on that axis, which lifts up the board, which sets us up for step 2. The next step, the slide. We start with the board up in the air where we left off before, and then we add a little bit of a sliding motion, which levels out the board, which gives you your height, essentially. So after we've leveled out with the slide, we then go into the landing, which is basically you pushing down a little bit more just so the board keeps with you and stops sliding. And then you end up with your ollie. You got a little air, you make the jump, that's it.
I've got to be honest, it's a lot to wrap my head around there. How exactly does this relate to a kickflip, though?
I wasn't finished talking. So you know the ollie, okay? We have, you start, you pop, but this is where the breakthrough happened. This is what humanity's been wondering for years. We don't know until now. The rotation. There's another axis here, okay? You pop off the nose, and it rotates.
I see.
No more 2-dimension, okay? No more 2. We got 3. With top down, and you can break this into vectors, okay? You can break this into vectors because it's an angle, but at the same time, you're still pushing that thing forward, but it's also rotating, which is neat. You need that angle for it. And this is like, I mean, you still have an ollie here. It's not anything different, okay? Don't overcomplicate it. Remember, 1 full rotation, okay? It's 1 full rotation. And then you catch it and push it down. That's how you stop it, okay?
Wonderful news, Doctor. Would you happen to have any closing remarks for us today?
Well, I'm glad you asked. Because we start over here. We're going to find the Newton force of a kickflip you're going to need to do. So we have your mass of your board is 1.9 kilograms. In order to find the moment of inertia along the center of mass, because remember, it's an ollie and a rotation. Then we have to do it at the angle, because remember, it's rotation and also pushing it out. So we have our moment of inertia 1/2 1/12 ml squared plus 1/2 m width over 2 squared, because we have to do the parallel axis theorem naturally. I mean, this is elementary. So now we break it into the 2 parts. So for the first one, with just the ollie, we have pi over 4 radians as our theta, and then like the difference in theta, and then for our kickflip, we have to do a full rotation, remember, so it's 2 pi. So basically, we found that we need for the ollie 1.373 Newton meters of torque and 4.814 Newton meters for the kickflip rotation. Now we got to go into the actual force. So basically, we know it's a component for the ollie because it's not actually straight, it's straight out, so the force needs to be kind of moved. So we have F cosine 45R equals torque. If you just look over here, so basically the torque equals force times radius, force equals torque over radius. We know it's 4.814 newton meters of torque, and then we have that over our width divided in half naturally. So it's 48.526 newtons. And if we add those two together, we end up with 53.643 newtons. One more thing. I want to demonstrate that I don't know snow physics, and so I'm gonna demonstrate a kickflip.
Apologies, folks. It appears that Dr. Coolius has had a couple of technical difficulties involving a skill issue. We are, in fact, going to go back to Ank, who is now in the field. We have found some skaters who have been implementing this theory for years, and we're going to show that off real quick, right? Right, team? Alright, thank you, Hank. Today, I am joined by Melvin Waterbird, and today, we are going to figure out exactly how the magic is done. So, how exactly did you crack this new formula? Was it more of a transformation of your motion, or what exactly do you do?
First of all, time, practice, determination. We got big morning breakfast, stuff like that. But really, what it's all about, dimensionality.
So, there was basically no time between introducing the third dimension from the ollie, transforming it into the kickflip. How exactly did that change occur out here in the wild?
Well, I can't say it was just spontaneous like me, man and passionate. I was up deep at night for myself. I do better. What could I do better? What could I do to improve this?
Yeah.
There long,
Like,
thought about it long and hard. And I thought, what if?
Is there anything else you'd like to add? Alright. It's some interesting developments out here at the skate park. Back to you, Hank. So there you have it, folks. Skating was revolutionized, and apparently it's not even that hard to do. It was just up to us to try and figure out how to do it. So, land properly, wear safety gear, and as always, remember to stay frosty. Hank Anchorman, Channel 11 Team News.
Peaches, 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 I love you.